My name is Nadia, and I'm an iOS support engineer here on the Mapbox support team based out of San Francisco. My day-to-day work is answering questions that come in to anyone who goes through our contact form or emails help@mapbox.com. We are the front lines, the support team is, on answering all of your questions and helping you figure out how we can help you build the application that you want. So, I got my start at Mapbox 2 years ago. I had used Mapbox tools in my previous job using a really old tool that you may have heard of called TileMill. I learned Cardo CSS, worked my way through coding, and I joined the team in 2016. And I've been focusing on iOS support exclusively for the past year or so. So we have a lot of use cases that require a different mix of tools. Our tools can be used standalone, but some of the best use cases that we've seen are actually when they're combined together. So today I'm going to break down some of the key APIs and SDKs for these cases that we see on an everyday basis. So this is kind of an overwhelming list. It lists all of our APIs and SDKs that we offer. A lot of these are often used together and depend on one another. There are a lot of options here, and it's a little bit scary. So today I'm going to talk about 2 stories that really highlight how Mapbox can help solve these common challenges with these location-based applications. Afterwards, we'll have a better sense of how these building blocks can be used together to deliver a great user experience. So to start our story off, we're going to talk about my theoretical friend, Janie. She needs to go to the store to pick up some wine and cheese for a very fancy party she's going to have. She thinks biking will be the best way to get there, and she's decided to take a local bike-sharing service to get to the store. So Janie starts by opening a bike-sharing app on her phone, and she notices there's a marker near her location displaying the number of bikes that are available. When she taps on the marker, a callout appears. It kind of looks like this. So she taps on the callout to get walking directions between her location and the actual bike share hub. When she gets to the bike and unlocks it, she is able to get it off of the hub to start riding. Janie is new to the city, and she wants to make sure she can stay on roads that are better suited towards cycling while avoiding hills that are too steep. So the bike-sharing app has built-in search and navigation that can get her to the store using the most efficient route specifically made for cyclists. She types in the address that she needs to go to and begins her ride. Since the bike-share bikes have a built-in phone mount, she can put the phone in between the handlebars and use that to guide her to the store. So Janie actually starts her ride using the turn-by-turn directions. A custom map shows what kind of road she'll be encountering, such as a shared lane marking or a separated bike lane. This is a draft example of what that might have looked like. So when she's done with her ride, she locks up the bike to the hub, and she gets a confirmation that the bike has been checked back in successfully. She heads into the store to finish up her errands after that. So a lot of tools went into this process that you may not see from the outside. So how did Mapbox help solve these challenges? Let's review each step. So to start, Janie located the bike when she opened the actual application for the first time. She searched for the store and got directions to the location. And then she used turn-by-turn navigation to actually navigate to the store by bike. And then when she was done with her trip, she locked the bike up and completed it. So here's an outline of the different building blocks that went into Janie's bike-sharing application. I'll run through each one, but this is the grouping of them all. So custom styles and data-driven styling, runtime styling, our Maps SDK, navigation SDK, forward and reverse geocoding all went into this entire application. So let's check out how that was done. Between our SDK and API offerings, again, this used almost all of our tools. So the backend data powered all of the different APIs that was used within this application. And an SDK was able to wrap around those APIs so that the mobile developers could continue accessing Mapbox tools and services without having to write any specialized code in a platform that they feel comfortable in. So to start with the custom styles and data, the bike-share app showed where the different types of bike lanes were on the map. The app developer did this by uploading bike lane data to their Mapbox account and then used the Mapbox Studio style editor to add and style the lanes. Because these styles work across platforms, the developers only had to create one style, and it could be used cleanly across iOS, Android, and on the web. The next two pieces I'll talk about at the same time. One was data-driven styling and runtime styling. This might have been some sort of vocabulary you've heard throughout your other talks today. But to recap, runtime styling allows you to dynamically change the map style displayed on your map in real time. So this allows you to customize every aspect of the map's appearance down to the smallest detail. You can change your map in response to user interaction, context, or build complex data visualizations by accessing the individual layers of a map at runtime. One example is that you can lighten or darken a map based on the time of day, personalize colors of parks based on user activity, or even change the label languages based on user preference. Data-driven styling, on the other hand, is a similar concept. Data-driven styling allows you to style your spatial data based on its properties. So for an example, with data-driven styling, you could change the radius of a circle at an intersection based on the number of pedestrians that are there. You can change the color of a state polygon based on its population, or you can even use conditional logic to create bilingual labels. So here it is in practice with our Maps SDK for iOS. So on the first line, we're creating an NS expression that grabs the bike count from some sort of internal API the bike-share developer is using. After that, we've got a stops dictionary with different numbers and color combinations. And then on the last line, we use the final expression to assign the color to the marker depending on the number of bikes that are at that station. This is awesome because then Janie doesn't end up going to a bike station that doesn't have any bikes. Because our mobile SDKs know how to style the data dynamically, we can color code these different features based on the data attributes. This is a representation of what it would look like with our Maps SDK again, which is also available in Swift and in Objective-C. This example is in Swift right now. So next up are the Maps and Navigation SDKs, which you probably have heard about today. The Navigation SDK itself is almost always used alongside our Maps SDK. And the Maps SDK provides the map visual, and the Navigation SDK provides the actual logic for the turn-by-turn directions and to show a smooth navigation experience. So the Maps SDK actually is included when you install the Navigation SDK on your device, because you're almost always using both at the same time. The Navigation SDK can be used with any of our supported transportation modes. So in Janie's case, she did use both a walking and a biking profile. So she first used the walking profile to navigate from her location to the bike-share hub. Once she got to the bike-share hub, that got switched to a cycling routing profile. And with cycling-specific directions, she wasn't routed on a highway or sent in the opposite direction on a one-way road. So users are routed to the right paths for the transportation type that they're using. And spoken turn-by-turn instructions make sure that users know how far away they are from the next maneuver and instructs them when to turn, such as this example that's telling the user to turn right on East 38th Street in 0.8 miles. So let's take a small look of what this would look like with our Navigation SDK written in Swift. So we have an origin and a destination, and then after that, we set the profile identifier to cycling. That's the only part that the developer has to use to change the routing profile. They don't have to configure any other settings to make this work. So after we've gone ahead and calculated the route under the direction shared calculate part, we create a new navigation view controller, which actually is a different view controller that displays the turn-by-turn directions, and then we start that at the end. So in the same bike sharing application, we're performing both forward and reverse geocoding, and I'll go through some examples of what that looks like. Our geocoding API allows users to search for places in the real world. To help developers work with that API, we have SDKs and plugins for every platform that provide some sort of smart default and snippets of simple user interface that you can build off of. So using the bike sharing app, in Janie's case, she was able to search for the store that she wanted to go to, which used the geocoding API to turn the address into real-world coordinates. And with features like category search and autocomplete, she didn't need to know the exact address to get to her destination. So the last component in reverse geocoding is to turn Janie's bike coordinates into an actual address. So it's often used for standardizing addresses or logging the location of something that occurred in the real world. In Janie's case, we wanted to make sure that the bike was actually locked up to the correct hub. So when the bike was actually locked, it performed a reverse geocoding search to turn the bike's coordinates into addresses, and then that's passed into some arbitrary function that the app developer has built to confirm that the bike has been locked up successfully. So here's a small example of what that might have looked like. Again, this is in Swift using Mapbox geocoder.swift, which is a library that we offer that wraps around our geocoding API. So we're going to start by creating reverse geocode options and passing in the actual user's location from the device's location manager. We start a geocoding process, and then we grab the first result, because often there are multiple results returned. From there, we grab the entire name of the returned result. So in that little comment above drop-off location, that's what it would look like. It would be a fully qualified address. And then we would pass it through this confirm bike return function, which again is some arbitrary function that would perform a confirmation that the bike was locked up. So to recap with this product chart again, this application actually touched almost all of our APIs in some way or another. I didn't even get into like the real nitty-gritty stuff, but these are the most pieces that you can take apart and put back together in some way or another. So again, in Janie's bike sharing app, they used custom styles and data, data-driven styling, runtime styling. They made use of the Maps SDK, the Navigation SDK, and they also performed forward and reverse geocoding. So Mapbox handles the data optimization and creates common APIs that can be shared between our web and mobile platforms. On top of all this, the mobile SDKs give you the ability to interface with these APIs within the same format mobile developers are used to working with. And a real-life use case that you may have seen earlier, our friends at Jump Bikes have almost an identical use case to Janie's story, using Mapbox to create a seamless bike sharing experience. So we do have tools pretty much for everyone. Janie's example shows how developers can build new, useful mobile applications using Mapbox tools. I'm going to transition to another story about a web-based product that shows how Mapbox can provide unique solutions to existing challenges. So this is another very common example that we see every day on the support team, people writing in. It has to deal with migrating some legacy map and adding new dynamic capabilities to it, all while working with multiple data types at the same time. So, second story. Phil is a developer for a local city government. His department is responsible for delivering an update to an old data visualization map his city publishes as part of their open data pledge. The map illustrates building information for various places throughout the city. The map that it currently exists is interactive, but barely. So, very similar to this weird snail emoji. It doesn't look great, and it's pretty slow. The data powering the existing map was also really hard to update. So let's look at what Phil wants his new map to do. He wants to rebuild it to be fast, more interactive, and filterable by a couple of different dimensions. So for example, he wants users to be able to filter properties by year, inspection date, and owner without having to reload the whole map or rely on an external database. Phil is working multiple data sources in different formats. Like I said earlier, this is a super common issue. On one hand, he has static data representing buildings in the form of a shapefile, and this shapefile has polygons with associated building information. On the other hand, his other data type is a JSON stream coming from a web API, and that's distributed from the property assessor's office. This JSON data has information about the different people that are associated with each building. So how can Mapbox help pull this data together to solve this problem? To start, we can help by working with multiple geospatial data types a breeze. So if you're working with GeoJSON, KML, shapefiles, even GeoTIFFs, we take care of making it look good for the web and mobile, so you don't have to do the heavy lifting. So here's a sample of Phil's data. He's got two sets of information that he needs to join together. One is a shapefile representing the buildings, like I mentioned earlier. The data has a unique building ID, construction date, and address. The JSON data is on the right, and that is owner data coming from the property assessor's office. This information includes things such as the building ID, the owner, and the registration date. Since the shapefile represents static data that won't change very often, it can be uploaded to Mapbox Studio to start with. So our Uploads API handles the conversion of the shapefile to vector map tiles under the hood. Once this is processed by Mapbox, the transformed data becomes a vector tile set, which is a collection of vector data broken up into a uniform grid of square tiles at 22 different zoom levels. While this seems complex, Phil doesn't have to worry about this because our pipeline handles this conversion automatically. Once the tile set has been created from Phil's shapefile, it can be added to a custom Mapbox style in Studio's built-in style editor. So from there, we can take advantage of Studio's new interface to dynamically style the features based on a data attribute. So for example, he could apply a different color based on older buildings versus newer ones. Or he could highlight ones that are due for inspection. So the Mapbox Studio style editor makes it possible to create a beautiful map style without any code at all. So I'll show you some examples of some other cases where we've seen great map styles coming out of Mapbox Studio. So here are some amazing data visualizations built with Mapbox Studio that actually live live at mapbox.com/gallery. If you're interested in learning how to go beyond the default when it comes to map design, we've got a great lab session at 4:30 by my colleague Amy Lee Walton. And she'll be talking about how you can apply the principles of design to create better maps for your users, really similar to the ones shown here. Jumping back to Phil's journey, now that he's got the style created in Studio, it's time to add the map to their website. And to do this, we introduced Mapbox GLJS, which is our most popular JavaScript library built to render performant vector maps on the web. You've probably heard it thrown around in a couple of talks already. So here's a very simple example of how to create a new interactive Mapbox map on a web page. Basically, you give it any Mapbox Studio style and HTML container element, and you've got yourself a web map. In this example, we're passing in a unique style URL that represents the map style made on Phil's account. That's why there's a fake Phil account there. While we've got a number of template and designer styles for you to work with, there's really nothing like displaying your own custom style you've created yourself on a website. So after the map has been initialized and Phil has gotten Mapbox GLJS integrated with it, the last step is to join the local JSON data with the building shapes that he uploaded earlier. So let's say Phil wants to associate the building shapes with their respective owners. Like I mentioned earlier, this data is dynamic, and it's coming from a web API. Mapbox.js can handle that too by parsing the information and joining it to the actual building geometries at runtime. So Mapbox.js is capable of joining the geometries to the uploaded static zoning data with the dynamically changing JSON data. The resulting data model might look something like this, where we can see building information attached to information about each building's respective owner. So what are the different ways Phil could actually visualize this with Mapbox.js now that his data has been joined? Why is this useful? Well, he could do something like this, where singular pieces of data, such as individual buildings, can be styled individually based on their new joined data attributes. So maybe he wants to color code each building based on their registration date, or maybe he wants to style them based off their construction year. Another example of what he could do with Mapbox.js is add interactive pop-ups that combine information about both the building itself as well as the owner. There are a lot of visualization options, but it's really cool to see how different organizations leverage the styling capabilities of both Mapbox Studio and Mapbox.js to make beautiful maps. So Phil's story is done. I'll go back and recap the different pieces that were used. He started this project by uploading the static building data. And since Mapbox Studio can handle the most common geospatial data formats, Phil was able to upload the building data in the form of his shapefile. And our Uploads API handled the conversion of vector data and reprojection without having to do any additional configuration. He then added the buildings to his custom style in Mapbox Studio. With Mapbox Studio, we've created a friendly web interface so that you can style your map without having to write any code. Our ability to include custom data and map styles allowed Phil to highlight the building data he added to the map. He then completed the entire data visualization and added the interactivity to the city website map with Mapbox.js. So since Mapbox APIs provide multiple ways to add data to a map, Phil was able to add the dynamic data to the map even after it had finished loading onto the page. So the resulting data was then joined at runtime with the existing building geometries. And this allowed users to filter the data directly based on zone, owner, and any other attribute the building and owner data might have had without having to reload the map, without having to reload the page, and without having to set up an expensive and difficult to maintain database. So we make a number of different tools to help you solve your mapping challenges. There are actually a lot more APIs that power some of our bigger ones under the hood, but for the most part, many of them can be used independently from one another. This is what makes Mapbox uniquely powerful. We give you building blocks for creating completely customizable applications that have maps, search, and navigation. So I work on the support team. We see a lot of stuff coming through the door every day, people messaging us. We really do love edge cases and seeing custom implementations. It's really awesome to be there on the ground on a day-to-day basis, seeing what people are working with. As a support engineer, I like these examples because this is all stuff that we've seen before. It's pretty common. So if you want to see more of the creative use cases about what people have done with Mapbox, my colleague Damon is having a talk tomorrow at 2:15 titled having to do with the misuse cases of Mapbox. There's really no wrong way, but these are the more creative ones that we've seen. And that talk is tomorrow at 10, or actually, this is a different talk. If you want to get more inspiration about how other companies are using Mapbox, we have another set of lightning talks tomorrow morning at 10:15 to learn more about how enterprise companies are creating really rich data visualizations to drive user experiences. And if you just want to start getting your feet wet,
check out mapbox.com/developers to see a complete listing of our API and SDK offerings. Mapbox.com/help has a variety of narrative explanations and tutorials that help further explain how the pieces fit together. We've got almost our whole support team here, and we'd love to hear what sorts of tutorials and examples you want to see coming up next. And if you can't get in touch with us within the next 2 days, hit us up at mapbox.com/contact. We read every message that comes in every single day. We're really excited to help guide you down the right path, and we can't wait to see what you build.